Welcome to Melac Online Tutorial. Alright, before us today is still this topic, specific heat capacity, and we're looking at this question. And it said a piece of copper ball of mass 20 gram at 200 degrees Celsius is placed in a copper calorimeter of mass 60 gram containing 50 gram of water at 30 degrees Celsius. Ignoring heat losses, calculate the final steady temperature of the mixture. And here we have the specific heat capacity of water to be this, and the specific heat capacity of copper to be this. Now, to bring this question to a source of reality, let me draw this. Now that here is the calorimeter. Okay, now, and we are told that the copper calorimeter of mass, so this one has a mass of 60 gram, now containing 50 gram of water. So let's assume this is the water here. Now the water itself is 50 gram, okay, and the temperature here is 30. All right, so which implies that both the calorimeter and the water has a temperature of 30 degrees Celsius. Now a piece of copper ball of mass, okay, now look at this. This is the copper ball, okay, let's say this is mass 20 gram. Now, and the temperature is 200 degrees Celsius, okay, and you can see that even this one is very hot, okay, and this one just within room temperature, okay. Now look at this. If this metal at 200 degrees Celsius enters this calorimeter, what do you think will happen? Okay, all right, now here is what happens. As it is being dropped into this water, okay, this is the ball. Now what happens here is there is a loss of heat, okay, by the ball, and as it enters, most likely this will what, increase. So there will be an increase in temperature here, okay, and there will be a reduction of temperature here. Now this reduction of temperature here, whatever temperature is being given out or energy that is being lost by the ball, is the same energy that we what gain by the water and calorimeter, okay. So which implies that the heat loss by this ball will be equals to the heat gain by the water in the calorimeter and the calorimeter itself, okay. Now if we tend to understand this, now this question is then solved, right? Now look at it. Take note that the heat loss by the copper calorimeter, okay, now equals to the heat gained by water plus the heat gain by the calorimeter, okay. Now here is the formula or the equation we'll be making use of, okay. And let us also recall that the heat is in itself equals to H, which is a product of mass, specific heat capacity, and the change in temperature. All right, okay. Now since we've understood this, now let us now come back to solving this, okay. Now let us know that the parameter, that the mass of the copper equals 20, okay. Now since the unit is given in joules per gram, so there's no need of converting this to gram, okay. Now the temperature of copper, that is the initial temperature of copper, is 200 degrees Celsius, and the mass of copper calorimeter is given as 60 gram. Now the mass of water is given as 50 gram. Okay, now the temperature of the calorimeter also is what, 30, and that of water is what, 30. All right, now the final temperature to which we are looking at now is theta. Okay, because the same temperature or the amount of heat that the copper ball will lose is the same amount of heat that the water in the calorimeter will gain. Alright, so let us now use this parameter, fit it into this. Then here we have for copper first, which is MCU CCU, okay, then 200 minus, which is this, okay. All right, then equals for the water. So here we have for the water, that is the mass of water, the specific heat capacity of water, then the final temperature, then minus 30. Okay, now plus for copper calorimeter, mass of copper calorimeter, specific heat capacity of calorimeter, and the final temperature minus the initial temperature. Okay, now let us start solving. Now this is what we're working with now. Okay, all right, so for the mass of copper, which is 20, that will be 20 times the specific capacity of copper is 0.4, then 200 minus the final temperature, then equals to, now the mass of water, this is 50, right? Okay, that will be 50, now times 4.2 as it is given, then theta minus 30, now plus copper, that the copper calorimeter, the mass is 60, then times that will be 0.4, which is the copper calorimeter. Now since the calorimeter is made up of copper, so definitely it will have the same specific heat capacity as the copper ball. So here you have theta minus 130. Okay, now you can now resolve. Okay, now 20 times 0.4, so give us 8. 200 minus the final temperature equals now 50 times 4.2, then we have 210 into final temperature minus 30, then plus 60 times 0.4, that will be 24 into what, theta minus what, 30. All right, now looking at this, for us not to stress ourselves much, you can see that 210 has this term, theta minus 30. 24 also have this term, theta minus 30. So that we, 210 and 24 has a common term of what? Theta minus 30. So let us factor out theta minus 30. So here you have, okay, opening this bracket here. So that will be 8 times 200, that will be 1006. Then times 8 times theta, that will be 8 theta. Then equals, now factoring out, you have what, 110 plus 24 into what, theta minus what, 30. Okay, so solving this one will give us the right hand side, 210 plus 24 will give us 234 into what, 30 minus what. Okay, so Let us now open the bracket for this. We have 1600 minus 8 theta, then equals to 234 theta, then minus 234 times 30 will give us 7020. Okay, let us now collect like them. Theta for theta, whole number to whole number. So let's bring 7020 to the left hand side. We have plus because it has minus here. 7024 then equals 234 theta minus plus, yeah, because 8 theta is having minus here. As moves here, it becomes plus. Okay, let us now add down plus 1600. That's for the left hand side. We have what, 8620, then equals 234 plus 8. You have 242 now theta. If you are dividing both sides by the coefficient of theta, which is 242, then our theta will be 35.6, okay, approximately 0.6 degree centigrade. All right, so this is the final steady temperature of the mixture. I hope it is now clear. Please share to your friends. Thank you and God bless you.